Today's problem, I tell you, really hard. I couldn't even understand the question properly, so I had to use AI. So basically, I just copied or tried to understand, but still struggling with solving it by myself. Anyhow, I'm still gonna upload whatever I did today. Let's start another day. Let's see what we have today. Okay, it's probably gonna be same matrix. Nope. Find the string with LCP, lowest common. I don't know. Let's read it. Given a long LCP matrix of zero index string word, LCP matrix of a string word and lowercase letters as an n by n such that, let me excali draw. Sorry. Okay. How do I? Okay, so we are given a matrix. Let's see what we are given. A matrix. Sorry, why am I grabbing a picture? So we are given a matrix. So there is just a matrix, and it is called LCP matrix, whatever LCP means, of zero indexed of a string, okay, of size n, and this is n and n by n. Okay, let me put this side by side so it's easier. Left to the screen. Okay. Okay, and each index, where is the drop button? And each ij is equal to the length of the longest common prefix. So value at this, so longest. Oh, LCP means longest common prefix between substring of bracket, so word I and n minus 1 and word j to n minus 1, common substring. Given a matrix, returns alphabetically a smallest string word that corresponds if there is no such string. If in the first position where A and B differ, the string A has letter that appears earlier in the alphabet as correspond. For example, A, B, D. A and B comes after D. Okay. So if we are given this matrix, so that's already built, and each value of matrix is the length of the common prefix between the two words. So if it's, so let's say for this example it's given 4. So 4 is the longest common prefix between the words. I is 0. Let's length here is 0 comma 2, and j is also 0. This stage in n is equal to 2. So that if a string, for example, so we have to build the string, right? And we have to define LCP matrix of zero index string word of n lowercase. So the matrix, the length of the matrix is the length of the string now, like number of rows in the matrix of n lowercase English letter of n letters. We define a matrix of a string of n character of n letters such as n by n grid, such that longest common prefix between substring of word. So longest common prefix between a substring. So if I have 0, 1, 2 ABA, a 4-letter explanation, LCP corresponds to a 4-letter string with 2 alternating letters. The lexical example. So we're given 4020. So the first value will always be equal to, I think we need to do some kind of reverse engineering here. Think about it. Looks like a DP problem, like some kind of dynamic. For example, so let's say if you're given the first thing 4020. So okay, let me build it again. Let me just this whole thing. Okay, so I'm given matrix. Doesn't matter. Okay, I'm given what 4 0. This is so annoying. Okay, let's just write the index. So we have, let me zoom in. Okay, so for the first string, 0 comma 0 is 4, 0 comma 1 is 0, so 0 comma 2 is equals to 2, and I'm just talking about the first row for now. So equals to 0. So what this means is, if LCP equals to length of the common of the longest common, what is a prefix? So let's say between substrings, if I have a string, let me type it here, A, B, C, D, E, F. So between, let me do it like this, A, B, C, A, B, D. Okay. So for each substring, so let's say if I have a substring A, B, and C, AB is the common prefix, and between substring A, B, and D, AB is the common prefix, right? And what we are given is for a square matrix, let's make it 4. Let's do, let me do it like this, AB, AB, the output that's already given. How do we come to this output from here? String A is, and each value is equal to the length of the common prefix between the substring word I to n minus 1. So if this is equals to word like n, so common prefix between word bracket 0, I is equals to I to n minus 1, and n is the, if it's 4 by 4 or 0 to 3, between again 0 to 3. Okay, and then what do we have? And we have the second one is between again 0 to 3, and now j is 1 between 1 to 3. So 0 to 3 is here, so 0, let me change the, because I think I zoomed in too much. So 0 to 3 is, so A to B, so there is no common prefix, like the whole thing is the common prefix, right? And then 0 to 3 is AB, AB, and 1 to 3, 1 B, AB. Is there, doesn't BA occur there? 0 to 3, we define string A is smaller than string B. Don't worry about the lexicography afterwards, but how do we think? Given a matrix of string word of n lowercase characters, what are the longest? So between the second thing, so when I is 0 and 1, that is 0, 0, and n is always 3, right? 0 and 3, and word when j is 1, so 0, 1, 2, 3. So between common prefix between AB, AB, and the longest common prefix between substring, if I have a substring AB, AB, and then BAB, B, what is the longest common prefix? Isn't it BA? Oh man, it's hard. What kind of topics? Array, string, greedy, union, find, matrix, use array. No man, this is too hard for me. I don't know. This problem, can't even think. How do I build a string from integer values? Let me read it one more time. You are given a long is to the length of the common prefix. Length of the prefix is given, that I get it, between two substrings. But why is it output AB, AB? No man, I can't. This is hard. Let's try and use AI to help understand this. Let me give it all the test cases as well. So where's my 1 second. Okay, I can't think of a string from prefix values. Break it down. If ij is greater than the word I is equal. Why? Because if two suffixes share a prefix of length, first character much man. Okay, that is correct. Group, if ij is greater than 0, then I and j must belong to the same group. So I've never done a union find. Use union find DSU to group indices. Step 2, assign character. We want, so traverse from, for each group assign the smallest unused character A, B. Now each index has a character. How? 0. We must verify the constructor string actually matches the given key recurrence. If word I equals to word J, F. Okay. Yes, walk me through example 1, as I don't understand as row 0 column 1 has 0 value but doesn't. BAB has common suffix B. Oh, longest common prefix. So it compares word I versus how many characters match from the start. For example, word was AB index. Okay, let's check it. Maybe you set row 0 column 1 equals to 0, but AB is a common. I equals to 0, J equals to 1. Now compare from the start. A versus B mismatch. Oh, so that means the whole thing we have to consider it as a string matching. Oh, so both are substrings and okay. So let's think of AB versus BAB. Okay. Now what do we have here? Start the basic. We get the length of the matrix. We loop through for each row if the row is not equal to if LCP I bracket I. So what's that? The last digit is not equal to n minus 1. N minus 1 equal return nothing. Okay. If it is equal, what is this term to see? Or we check the last cell, including the last one. So LCPFI suffix. So what? Oh, sorry about the background noise. So LCP length of the suffix is equal to 4. We're checking yes for the last index. So what it's checking is okay. If LCP is not equals to n is the length of row and column minus 1. So what is LCP? It means compare the suffix starting at I with itself. So we are comparing. It should always be answer should if we compare a string with itself, the whole string match. So it should be equal to yeah, that's correct. What is the suffix length from index I to n minus 1? Correct. So the check is checking does the matrix correctly say the suffix. If not, matrix is invalid. Oh, I see. So we're checking if got it. Basic before we check if by itself symmetry if ij because it should be same, right? Yeah. If ij is greater than 0, then what do? We pause and think what's happening here. If ij equals to 3, word I, DSU only handles I to j. How are we making explain this union find? Really understand DSU from we need to group indices that have the same character. Exactly what union find keep track which elements belong to the same group. How it works. Think of each index as song group. Initially you have 0, 1, 2, 3. So when we see greater than 0 we merge them. For example, n0 and 2, CP of 0, union of 0 and 2. So we do union plus match. Oh, this is going over my head. So what's happening here is okay, so we have initially integer n is equal to lcp dot length, like the number of characters. Okay, and then first we have to check for integer I equals to 0, I must be less than equal to less than n for sure. I plus plus. First check, what are we checking? First check in if I equal to j, then results should be same. So what we have to do, we have to check if lcp I bracket I and I and j are same is not equal to n minus I, we return the function, return an empty string. Okay, and then we loop for columns. For j equals to 0, j must be less than n. Again, it's a square matrix. J plus plus. And if another is if LCP of ij is not equal to ji, because j is not equal to also the prefix of j and I, we return an empty string as well. Yeah, these are the two validation. Now we have to check. What are we checking? Let's create an integer array called parent, which is equals to new int of size n. We have an array parent. So for each, for integer I equals to 0, I must be less than n, I plus plus parent bracket I equals to I. So for each array I'm giving it the values, and then we have another loop for I equals to 0 must be less than n and I plus plus. We loop through the columns too. For each of j equals to 0, j must be less than n, j plus plus. Okay, and now what are we checking? If our LCP of I comma j has a value like it's greater than 0, then we do a function called union of parent. We haven't defined the union yet. Is union a built-in function? Let's find it later on. So I'll have a character array result equals to new, because we have to build the array. Character array of size n, teacher an array group new and of size add. Okay, so I'm gonna fill the arrays dot fill name of the array on of each group with the value -1. Okay, integer max character equals to 0, and then I have a loop for I equals to 0, I must be less than n, and I plus plus. Okay, the root find of find group -1. And what do we have? If our root equals to f group bracket root equals to -1, and if next char e6 good. Okay, if group if next char is greater than 26 characters, return this, and then we save the group bracket root equals to next plus plus result I equals to character of a minus group of root. Okay, now we have to validate the LCP. What does validate the LCP means? Integer array check function, no check matrix n for I equals to 0, I must be less than, and I equals to n minus 1, I must be greater than equal to 0, I by this minus. Similarly we do it for our columns. For column equals to, let me rephrase the term to j equals to n minus 1, it must be to the j minus minus. We check result of I equal to result of j. If yes, then what we do? If I plus 1 is less than n, if I plus 1 is less than n, and j plus 1 is less than n, I plus 1 is, if I plus 1 is, sorry, less than n, am I doing greater than n? If both of them are less than n, then we check if check I and j, what do you want to check is equal to 1, plus I have very less faith in this problem. I'm gonna come back later on in the evening to actually understand what's going on, because right now I can't make any little to no sense of out of it. And j, let's check I and j. And if our check I and j is not equal to LCP of j, return the empty screen, and then we have to return of s. Then we have the functions that we gotta do. Private and find function that does all that takes an integer array of parent and integer x. If what? If the parent at value or index is not equal to x, parent bracket x equals to find what? Find parent comma parent bracket x, return bracket x. And then I have a union function, private void union, that takes in the same So take an integer a and an integer b, and pa equals to find parent comma a, integer bb equals to find parent comma b, right? And if they are not equal, and if a is not equal to parent b, parent is equal to parent. Definitely some gonna be typos anywhere. Who's screaming in the back? Looping for all inches. I'm definitely gonna come back and revisit the problem later on. Right now, it's not sitting right with me. Yeah, I think this is it. I feel mentally exhausted right now. I'm gonna eat something and I'll come back and visit this.